Gallium is a fascinating metal. It has unique properties. One is its ability to weaken aluminum. It infiltrates the structure of this common metal. The results are dramatic. Gallium is a soft, silvery metal. It looks unassuming, but its interaction with aluminum reveals a different story. It's a story of chemical bonds and structural weaknesses. This interaction has significant implications. It affects industries from aerospace to construction. That's why understanding gallium is crucial. It's a key player in the world of material science. Aluminum is strong and lightweight. It's used in countless applications, but it has a weakness: gallium. Gallium atoms can infiltrate the lattice structure of aluminum. This happens at the atomic level. Gallium atoms disrupt the regular arrangement of aluminum atoms. This process is called liquid metal embrittlement. It weakens the aluminum significantly. Imagine a building with cracks in its foundation. That's similar to what gallium does to aluminum. The once strong metal becomes brittle and prone to failure. It's a slow and silent process, but the results are undeniable. Gallium is known for its low melting point, making it a unique and intriguing element in the periodic table. It melts at just above room temperature, at 29.76 degrees Celsius or 85.57 degrees Fahrenheit. This is quite unusual for a metal. This means you can melt gallium in your hand. Imagine holding a solid piece of metal and watching it transform into a liquid right before your eyes. Hold a piece of gallium and it will slowly liquefy. The process is mesmerizing, as the solid metal gradually turns into a shimmering liquid. The heat from your hand is enough to do it. Your body temperature, which is around 37 degrees Celsius, is more than sufficient to melt gallium. It's a fascinating demonstration of its unique properties. In science classes, gallium is often used to captivate students' interest and illustrate the concept of melting points. It's a stark contrast to other metals, most of which have high melting points. Metals like iron and copper require extremely high temperatures to melt. This low melting point isn't just a curiosity. It has practical applications in various fields, making gallium an important material in modern technology. It has significant implications for gallium's use in various applications. For instance, in electronics, gallium is used in semiconductors and LEDs. From thermometers to semiconductors, gallium's low melting point is a key factor. Its ability to melt at such a low temperature makes it versatile and valuable in many technological advancements. Section 4. A low melting point metal. Only a few metals have a lower melting point than gallium. Mercury, cesium, and francium top the list. But gallium's combination of properties makes it stand out. This low melting point is due to the weak bonding between gallium atoms. The bonds are easily broken with a small amount of heat. This makes gallium highly reactive and useful in various applications. This property makes gallium fascinating to scientists and engineers. It opens up a world of possibilities in materials science, electronics, and other fields. Section 5. Gallium's significance in material science. Gallium's unique properties make it invaluable in material science. This silvery metal is not only fascinating to look at but also holds a special place in various scientific applications. Its ability to alloy with other metals is exceptional, allowing for the creation of new materials with enhanced characteristics. It creates materials with specific properties, tailored to meet the demands of modern technology and industry. For example, gallium arsenide, or JAS, is a semiconductor that plays a crucial role in the electronics industry. It's used in high-speed electronics and optoelectronics, enabling faster and more efficient devices. You'll find it in smartphones, lasers, and solar cells, making our everyday gadgets more powerful and efficient. These applications are revolutionizing our world, driving advancements in communication, energy, and technology. Gallium is also used in alloys with low melting points, which are essential in various industrial processes. These alloys are used as solders and high-temperature thermometers, showcasing gallium's versatility. Its versatility knows no bounds, making it a key material in numerous fields. It's a testament to the power of materials science, highlighting how a single element can have such a broad impact on technology and industry. Section 6. The Future of Gallium. Gallium is a metal of the future, a material that holds immense promise for technological advancements. Its unique properties have captured the attention of scientists and engineers worldwide, sparking a wave of innovation. Research is ongoing to explore its full potential, with laboratories around the globe dedicated to unlocking its secrets. From creating new alloys to developing advanced semiconductors, The possibilities with gallium seem endless and transformative. Gallium is playing a key role in shaping the future of technology, influencing everything from electronics to renewable energy solutions. Its impact will be felt for generations to come, as it continues to drive forward the boundaries of what is possible. As we venture further into the 21st century, gallium stands out as a beacon of innovation. It's a metal that embodies the spirit of progress, pushing the limits of current technology and opening new frontiers. Gallium is a testament to the endless possibilities of the universe and the power of scientific exploration, reminding us that the future is bright and full of potential. Thanks for watching. Like and subscribe for more quick science bites.